Hey everyone, Mrs. Slauson, and here is your review for the Chapter 4 test. Let's just go ahead and get started. So in the first section, we are finding inverses, and the key thing in inverses, when you find an inverse, is you need to switch your x and y around, and then just depending on what the problem is, your next steps will be different. So just a reminder, when you see all of these f of x and g of x and h of x in that type of row, that is technically just your y. So I'm going to go ahead and switch my x and y around. And in the top row, your goal will be to get y by itself. So here goes my little line. The first thing I'm going to do is add 8. So when I add 8, that leaves me with just the 2/3 y on the right side and x plus 8 on the left side. And then to get rid of the 2/3, what I will do is multiply by the reciprocal. So that will get rid of the 2/3 on the right side. And on the left side, I'll also have to multiply by the reciprocal, but I'm going to multiply all of it. And what I'm going to do now is just distribute to simplify this. So I'll have 3/2 x, and 3/2 times 8, you can type that in your calculator. But in the end, you will get 12. And then if you remember, write the inverse version of our function. Okay, B, same thing. So just go ahead and get started. Switching x and y around. And now my goal is to get that y by itself. So the first thing I'm going to do is add 3 to both sides, which leaves me with just the cubed root of y on the right side and x plus 3 on the left side. The next step is I shall cube both sides, which will just leave me with y plus 1 on the right side. And then I'll have to remember to cube all of the left side. So whenever I do something to all of it, I will wrap it in parentheses. And I'm just going to leave it as x plus 3 cubed, because otherwise I would have to do x plus 3, x plus 3, x plus 3. I'd have to have all those neighbors meet, and I don't want to do that. All right, next step, just subtract the 1. And when we're done, we're going to have an x plus 3 cubed minus 1. The 1 will not be in the parentheses, and instead of y, hopefully you remember, change it to the inverse version of the function. All right, so there's our final answer for this one. And one more. So again, getting y by itself, I'll subtract the 5, which leaves me with 2y cubed. On the left side, it's x take away 5. The next step, sometimes people miss this part, is I will divide by 2. And I'm going to make sure I divide all of x minus 5 by 2. So I'm going to make a very long fraction bar and divide all of it by 2. And then the last step is I will cube root, and I just want to make sure that I cube root the entire left side. So make that check mark really big, make sure all of x minus 5 over 2 fits in it, and then instead of h of x, we will write our inverse function. Okay? All right, if you have a picture, then what we need to do is switch the points around. So first establish what are the x's and y's we're going to work with, and then just switch them around. So right now, my x's and y's, let's try to get this color. For the current graph, these points right here are 2, 5, 3, 3, 6, 1, and if you notice the last one, that is 8, 0. So all I'll have to do is just take those points and flip them around and then graph those. So instead, 5, 2, 3, 3, 1, 6, 0, 8. So I'll go ahead and just graph those now. So here's 5, 2, 3, 3, 1, 6, and 0, 8. And if you notice, it started at the 2, 5 and kept going. So now what I'll do is I'll start it at the 5, 2 and go this way. Okay? So just one more highlighting that out. arrow on this side, but not on the other side. So there's my first inverse. The next one, same thing. I'm just going to take these points that are already established. They are 5, 4, 3, 0, and 0, negative 6. And now I'll just switch them around and graph those points. So instead I'll graph 4, 5, 0, 3, and negative 6, 0. So 4, 5, 0, 3, negative 6, 0, and then I'll just connect another line, arrows on both ends. All right, here we go. Multiple choice question. Which graph does not represent a function and the graph of its inverse? So since these are pictures, what I want to do here is I want to establish some x's and y's for one function, for the other function, and if they are switched, then we're good to go. So mine printed in color, yours did not. So what you're going to probably see is like this being one shape, this being one shape. You'll see these squiggly lines like standing out. This one, let's do this shape. And we will save D for last. All right, so going with the part that has the squiggles on it. I just want to find like maybe 2 points that I could then switch. So when I was looking at graph A, and this is my y-axis, okay, this is my x-axis. The points I established were right here, and then looking right here. And so starting with A, and I think I'm going to write, well, I'll just put A right here. So I'm going to have, for my original points, 0, 5, and the other one, if you count over and up, you'll get 8, 7. So that means when I go to the new graph, I should be able to locate the points 5, 0, and 7, 8. And if I can, then I have a function and its inverse. So here's 5, 0. And then if I go over 7, up 8, there's that point. So this one is a function and its inverse. So if we go to B, again, I'm going to do the same idea. I'm going to locate a couple of points. So if I go on that squiggly line right now, let's see, points that I know for certain. So I've got 0, 0. I'm going to write this right here. This point and this point. So I know I have 0, 0. I've got a 1 and negative 1. I've got a 1 and a positive 1. And then I thought I would just go for one more point. And so I went over here and I thought it was down 3 and, or sorry, left 3 and down about 1.5. So left 3 and down 1.5. So now I'm going to switch these points around and just see if they are on the other shape. Okay, so 0, 0 is, it's right there. I'm going to go in black. Negative 1, let's see, negative 1. Sorry, I didn't realize this was a negative 1, so let me switch that around. A little correction there. So I'm on the orange point, and I do notice a negative 1, 1, 1. And then I'm going to see if I go to, excuse me, over 1.5 to the left, down 3, am I pretty much on my graph? So if I go over about 1.5, down 3, I end up right here. And so yes, this one's a function and its inverse. So A and B are good. Let's take a look at D. So D might confuse you because it is one line. But it's actually, what we can't see is that it's one line right on top of another. So I'm going to pick a couple points, and there should also be arrows here. And I'm just going to pick a couple points and see if I switch them, are their inverses also there. So let's take this point, and this point should work. All right, so finding these coordinates first. So I've got -2, 3, I have 0, 1, and I have 2, -1. So if I switch these around now, I should be able to find 3, -2, 1, 0, and -1, 2. So let's see if that happens. So here is 3, -2. Yep. Here is 1, 0, and here is -1, 2. So as it turns out, in this particular one, the graph of the function and the graph of the inverse are actually the exact same functions. So this one works too, which means it does have to be the last one. So let's just verify why. All right, so I'm just going to zoom in a little bit here. So I'm going to take the top part. I'm going to find some points, a couple points. So let's take this point, and this point. All right, so working left to right, I've got -3, 3, 0, 0, and 4, 4. So if I switch these around, I should be able to find 3, -3 on the new shape, 0, 0, and 4, 4. So I'm like looking to see if those points are down here on this part. Okay. All right, so here is 3, -3. Good. Here is 0, 0. Well, let me put that one black. Actually, I'm going to X these. So far, so good. But then here's 4, 4. And as it turns out, it's not going to work. I needed something over here, not here. So this one is a big no. This is not a function, and it's inverse. There's just not enough points to match up. All right, let's keep going. All right, read the question and write your response in the space provided. So we need to use this given graph of f of x to find some coordinates from the inverse function, all right? So right now, the inverse function, so let's draw this little wall. So again, this is about f of x and the inverse, right? I need to figure out what f -1 of 4 is. So I need the y value if in the inverse function x is 4. So I know x is 4. I need to know the y value. So what I'm going to do is take the original function, and if this is x in the inverse function, then just remember it was y in the regular function. So I'm going to go to the regular function, and if y is 4, what's the x? So I'm going to go up 4, and when I look left, I don't see anything, but when I look right, I see that x is 2. And so now, if these are the coordinates of the regular function, then when I switch them, these are the coordinates of the inverse function. So my final answer in the inverse function, if x is 4, my y value is 2. All right, which function represents the given graph? So the first thing I'm going to do is do a little bit of eliminating. I'm just going to take out c altogether because that's a cube root function and this is a square root function. And I'm going to notice that from 0, 0, I went right 3, down 1. So right 3 would be this. This would tell me to go right 3 and down 1. So I can already eliminate A, and as it turns out, I can eliminate D, and my final answer is B. Now, let's say we still couldn't tell. Then if you remember, you can figure out what this A value is if from wherever 0, 0 went and you go over 1, how many do you go up to land on a nice point? And we go over 1, and we go up 2, which is why we're going to have a positive 2 here. All right, let's see. I think at this point I'm going to pause. Well, let's see. I don't know. I don't know if this video is going to stop me in 30 seconds or not. So it would be nice just to finish up this page on this video. So let's see what happens. All right, determine if f and g are inverses, and you have to use function composition. That's what I'm seeing if you know, which is written over here for you. All right, so what I'm going to do is get these set up here. I'm going to do that on all the problems. Okay, my goal is to take G, put it into F, and F, put it into G, and simplify it. And the goal when I simplify is to get to X. If I don't get to X, then no, they are not functions of each other. So in the first one, G is going to go right here into F, right there. So I'll still have the 3, but in for X will go this. And then I'll still have the -9. And then I'm going to go ahead and set the other one up that says I should take f of x and put it into g. So again, just setting this up. So here goes 1/3. Instead of x, I'll be putting in the 3x minus 9, but then I'll still have the +1. So you can solve whichever one you want first. Maybe you think one looks a little easier to you. For me, that would probably be the one on the left. So 3 times 1/3, or 1/3 of 3 is 1, or 1x. 3 times 1 is 3. I'm distributing, bring down the -9, and when I'm done, I get x minus 6. I didn't get x, so I already know the answer is no. But let's say you thought to do the other one. Then 1/3 of 3x is still just x. 1/3 of 9 is 3. Bring down the 1. Then when I simplify this, I get x minus 2. So again, I didn't get x. If you don't get x on one, don't bother with the other one. You don't need to. All right, next one. So here we go. Let's take G and put it into F. All right, so I'm going to have the parentheses. In for x will go all of this. So I'll put a cubed root x minus 5 minus 2. So that all went in for x, this x right here. Then I'll still have the +2 with the cubed and the +5. I'm going to go ahead and set up the other one. And so in the other one, let's do a little erasing. I will take, let's see, F, and put it into G. So I'll have my cube root, but in for x, you know, this x right here, I'm going to put x plus 2 cubed plus 5, and then I'll still have the -5 in the check mark, and then the -2 out of the check mark. So again, you kind of have to figure out which one you think looks easier to solve. For me, I think I'm going to do the one on the right because I have a lot of stuff in this check mark, and I'm going to start simplifying that. So when I look in the check mark, what I notice first is I can get rid of the 5s first. So I'm going to make a little note of that. I got rid of the 5s first. That brings me to this. And then what happens is within the check mark, x plus 2 is being cubed, and it's also being cube rooted. So that's the next thing I can get rid of are these little cubes. So I got rid of the 3s, which leaves me with just the x plus 2 with the -2. And then the last thing I can get rid of the 2s. So in the end, yes, I just get to x. So if I get to x on this one, I'm probably going to get to x on the other one. So the nice thing about inverses, when it's not a linear function and it's inverse, like on A, if you started with 5, then simplified the 3s out, then simplified the 2s out, then what you're going to do on the other one is get rid of the 2s first, then the 3s, and then the 5s. So that kind of helps me find a path here. So when I look inside those parentheses, there's some 2s that I can just simplify out. So I got rid of the 2s. Then I can get rid of the 3s because something cube rooted and cubed will cancel each other out. And then finally, I can just get rid of the 5s, and I get down to just an x. So this one, these are inverses. All right, that is our first page. I'm going to stop the video here. So our next section will be getting into graphing.